Hello everybody, Bill Harrison here with Hardened Power Systems. Wanted to take a few minutes, once again introduce you to a new product for us. This one's a bit unusual, kind of exciting. It's been quite a while in the works because it took a lot of tinkering and prototypes and stuff to make it work. I'm assuming that when you look at this, you have absolutely no idea what this is. And this, in fact, is 5 pieces. This happens to be the way they come off of the 3D printers. But by way of introduction, let's talk about something near and dear to our hearts. Anderson power poles. In my opinion, with no reservations, this is the most flexible, lowest loss, most reliable, most dependable method of connecting DC power in virtually anything you're doing. I just got to say, frankly, I kind of wish I'd come up with this, because I'd like to shake the hand of the person or people that actually conceived this and then got it to a point where it's so close to just being perfect. In any event, we use a lot of Andersons. They're used throughout our gear. We will, I'm sure, continue to do so. They are a bit addictive. I'd warn you that if you start using Andersons, whether you're a ham radio guy or a portable power guy, or you're building equipment that uses DC power, and it's not limited to DC, it's just typically used for DC. But again, you can kind of get bit with the bug and wind up spending a bit of money and a lot of time converting your equipment over to Andersons. So enough said about how awesome these are, unless I just need to say again, these are awesome. Anyway, in my mind, Andersons have 2 shortcomings, which is funny after I just talked about how awesome they are. The first shortcoming I feel as though we solved several years ago. That shortcoming is a difficulty in panel mounting. And if you want to see what I'm talking about, just look at a product that we build and sell called the Anderson Auto Grip. It's essentially an HDPE block, a plastic CNC machined mounting block that these press into very securely. So if in my opinion Andersons have 2 shortcomings, again I feel as though we solved one with the Anderson Auto Grip. The other one, it takes some time for the weakness to reveal itself, and it's not particular to Andersons. It's a common problem with electrical connections that are done by way of any sort of modular plug and a cable. And what that weakness is a lack of a good strain relief. There are 2 types of strain that most connections can suffer. Probably the most obvious is a pull-out force, and this is, for example, addressed by Apple with their magnetic power connection for their laptops. Right? The idea is that if the laptop is plugged in, sitting on a table, somebody walks by, trips over the cord pops out of the machine instead of dragging the machine off the table. So, pull-out force, it can be an issue. And it's not that I think that Anderson should actually come unplugged from one another easily. In fact, the fact that they don't do that is a good thing, of course. But that very same pulling force can pull out or damage the connection of the Anderson and the wire inside the Anderson power pole. So of the 2 types of strain that you're trying to address or relieve, one is a pulling force. I think that the Andersons handle that actually quite well. If you're familiar with the internal design of a power pole and how the internal contact comes in and then clips over, in fact, let's just see if I can't show you. It might be hard to see, but This is the internal contact used in an Anderson, and this little curve, this little detent at the end, very securely locks into the shell or the plastic housing. So of the two types of strain that we're trying to address, the pull-out force I think is less of an issue with an Anderson, but the second one is a problem, and that is when you have a wire crimped into a contact like this, and that contact in turn is inserted into the Anderson, that if you have any significant amount of play here where the wire exits the Anderson, what you get are microfractures. Of course, typical DC hookup wire is not a single wire. It's composed of a great many thin strands, and because the contact terminates abruptly, right? It's got just simply a flat end that terminates, and this is crimped down on that stranded wire. As flexing occurs, you get microfractures in those wires, and once the first few start to break, you've got two problems. One is the resistance in that circuit starts to climb because you no longer have as much conductive material as was intended, and then failure, outright complete failure, disconnect, breaking of that wire is pretty much inevitable. The thing that really brought this home for me was our 3D printers. We run I guess you'd call it a printer farm. We run a large number of printers, and they run a lot. If we're doing our job, they're running 15, 20 hours a day. And the printers actually use Andersons as some of the connections between the machine and the table that articulates. The table moves in X and Y. So, dealing with that repetitive movement of the wire entering an Anderson, and I can tell you that's a very, very common failure mode, to the point where it really caused us to take a step back and see what we could do about it. And as they say, necessity is the mother of invention, and that caused us to do some work trying to come up with a type of strain relief. And let me see. Here we go. So the first thing we came up with was this. And this is just a 3D printed two-part shell. And that shell wraps around the Andersons and pinches the wire. And it's assembled normally without any adhesive. It really doesn't need it, but just a single stainless steel screw. And this worked for us. This worked very well. And by for us, I mean there's some warnings here. This is frankly rather delicate. This shell is a very thin wall shell, and there's some geometry inside and stuff that creates some weak points. But it's really only weak until it's installed, and then it's very durable. It is something you have to handle delicately until it's installed. Also, I think that a shortcoming of this is that the diameter of the exiting wire is fixed. You can try somewhat to accommodate slightly different wire diameters with a single hole size there. But again, this worked for us because we had a very specific purpose, and we have actually built these into quite a few cables that our customers have. But it's always in a scenario when we are making the cable. So we deal with the fragility of this part until it's installed and suddenly becomes very strong. So, when this was briefly shown on a video at some point in the recent past, and boy, we got a lot of inquiries from people who were saying, hey, strain relief for the Andersons, finally, how much are they? What, when are you going to sell them? And frankly, we weren't ready to sell them. That of course is something we always try to be mindful of, but this is not really suitable, I don't think, for an over-the-counter item that a person is expected to effectively install and use and be happy with without being able to scrap out a couple pieces or really understanding how they work. So anyway, all that to tell you that this is really the evolution of the strain relief you just saw. It does a remarkable job of solving the problems that I was just talking about. That said, let's just let's build one. So we've got a pair of Andersons in the standard red right, tongue up format. Piece of 12 gauge zip wire, very common stuff. So we will prep this wire for Andersons. And I realize if you're watching this and you're familiar with Andersons and you've installed a lot of them, you're very familiar with what I'm doing. But I've got my wires stripped at an appropriate length. I'll slide my first contact on. Use some crimpers that are meant for the purpose. Now, I will say, if you're considering using Andersons, please go ahead and spend the $30, $40 and get a proper set of crimpers that are intended for Andersons. It will take a potentially difficult job and make it easy. No solder needed on these. People can kind of debate that. My opinion is that I do not want to solder these because I do not want to introduce or exacerbate those microfractures that can occur in the wire strands. So in any event, we've got our Andersons. We're going to install them into the Anderson. And I don't know if you heard that, but there's that satisfying little click when those crimped contacts slide over the overmolded contacts and engage and snap in. And that mechanical relationship is why I say that the type of strain, which is a pulling strain, is really not much of an issue on Andersons. If you're pulling that hard on these things, then there's some other problem. So in any event, we've got the Andersons hooked up. We'll take a pair of our printed strain reliefs. And I will say too, these are white primarily because I wanted something that would show up well on camera. I expect that the ones that we will sell and ship and use in our own stuff are going to be probably black. In any event, these shells, these halves, are symmetrically opposite top to bottom and left to right. So there is no top or bottom. There is no left or right. They really can't be done wrong. It slips in. You notice this notch on the Andersons and a corresponding spud on the little shell. So again, it kind of can't be done wrong. It simply fits in where it wants to be. And then the other half slides on just like that. So right now it's not going anywhere as far as like left to right this way, but obviously I'm just holding it on there. Now, next is kind of the key that makes this unique system work. This is a really nice, we use a lot of this of different sizes, but this is a very high quality dual wall adhesive lined shrink wrap with a 3-to-1 ratio, a real aggressive shrink ratio. It's very thick walled. I mean, you feel this, it's almost like a chunk of rubber. Now, if we slide this on to our pair of strain reliefs and eyeball it perhaps about up to that point, meaning you've got about this much visible. Now we're going to hit this with a heat gun, and you can do this with a lighter, you could do this with a hair dryer, but if you're going to do a lot of it, or you're going to do it as well as you can, spend the $20–$30 and get a heat gun that's built for the purpose. So now this is quite hot, and if you can tell, that shrink is drawing those little tulip-shaped clamps in around that wire. Now, frankly, I'm pretty pleased with the simplicity of this design, kind of the elegance of how it uses the mechanical compressive force of a good shrink to turn that into not only something that now permanently holds this shell closed, these Andersons cannot come out, it addresses the pull of the strain relief to some extent, although honestly that's not really the primary goal. The primary goal is eliminating this action from translating into the point where the wire enters the Anderson contact. If you can overcome that, then you've got a connection that is not going to fail based strictly on movement of the wire. I know this seems like maybe a simple problem to try and solve. Oftentimes the simple ones are the ones that are a bit of a trick. But in any event, you can see that here with this 12 gauge, that does a real nice job of clamping down on that, gives you something nice to grab onto. And then just by way of example, here is one of our prototypes that happened to be printed in yellow. Now this is a much thinner 18 gauge wire, and you can see that it was still able to collapse enough to bite on that wire and to do its job. Here's an example. Now this is one of the cables that we make here. It's a battery clamps to Anderson, a 6-foot beefy 10 gauge wire, and same thing. You can see that with the 10 gauge, that's a really secure clamp. Now, if you were using Andersons in a static environment where they really saw little or no movement, I guess I would say there's probably no reason for you to worry about this device. But I would definitely say if you're using Andersons in an environment where they're being plugged in and removed frequently, or they're attached to something that is itself moving, or if it's something that's mission critical, something emergency comm related or military related, these I think make sense. And happily, like a lot of the things we make, I can honestly tell you I'm not aware of anything else out there that does this. They do make rubber boots, these, and these are common, and they've got their place. We use them sometimes. They're not expensive. It's a nice little PVC, but really, this is properly a dust boot. There's no moisture resistance or mechanical strain relief associated with this. It kind of cleans up the connection, and it's a bit of a dust stop. So it's not bad. It's just not doing the same job. In any event, I believe this is how we will ship and sell them. So they'll need to be torn off of the small base that facilitates printing. I do expect to ship them with a corresponding number of this real nice shrink, so you don't have to worry about trying to find this or buy it or deal with that or whatever. I guess I'm looking forward to seeing, kind of like our auto grips, we get so many cool testimonials from people about how they're using them. I'm looking forward to seeing what you folks do with these. We'll have them up on the website soon. This is early July 2017 when we're shooting this video. So we'll have them up on the site, and we'll do our best to price them fair and ship them fast. And I guess as always, everybody, boy, we so appreciate you guys. I just can't say enough how we've got the best customers in the world. You guys are just fabulous. And our families thank yours. So anyway, go to portableuniversalpower.com. And honestly, I'm realizing right now, I'm not sure what we're going to call these. But they'll be under the accessories, some sort of a strain relief. and look forward to hearing what you guys think of them and what you do with them. So anyway, this is Bill Harrison with Hardened Power Systems. Take care, everybody. We'll see you.